in case you're like me right now and just not feeling it. Okay, so ladies and gentlemen, welcome. We are here going on day 2. Yesterday, we did, we're talking about all the definition terms, all that kind of stuff. So if you did not get that, make sure you go to the video right before this and you get all of that. You probably will need your calculator. So I'm gonna pull that up too. There's my calculator. And we're going to talk about writing each equation in radical form or write each radical in exponential form. So really quickly, looking at this right here, I want you to put in the chat for me. Tell me, is this exponential form or radical form? If you think it's exponential, you'll put an E. If you think it's radical, you'll put an R. Let me just see. So excellent, ladies and gentlemen, you notice there's an exponent. Therefore, it's in exponential form, meaning that we're going to write it in a radical form. Remember, a radical is like that, right? That's a radical, yes? Okay. So I think what was really important, especially after yesterday, right? We talked a little bit about this one. It's important to remember that 12 has an exponent of 1, right? The exponent of 1/2 only applies to m, right? And so this is what I'm going to say. If the exponent is a fraction, then it can be under the radical. Otherwise, he's not invited in, okay? It's an exclusive club only for variables that have exponents or bases that have exponents that are fractions, okay? So this 12, can he go under the radical? No, he is going to stand outside just looking in, okay? Kind of sad, but there he is. But he's still multiplying times everything, right? Okay, then we're going to look at our form. Now this form is located, it's this right here when we were talking about this right here. And y'all know that where that is located on your sheet. It is the last one. No, it's the next to last one, rational exponent. See, I'll show y'all. Right here, this rational exponent. And see how it has like a base with a fraction as an exponent, and then it tells you how to write it in radical form. So we're going to be using that as a visual. So I'm going to go ahead right here, and I'm going to label. According to this, the numerator on top is m. The denominator on the bottom is n. And my a is what? What's my a? 12m or m? Just m. This is an important distinction, yes? Okay. So when I write this, remember 12 wasn't invited in because he has an exponent of 1. So we're going to rewrite this so that we have a to the power of m underneath. So a is m. And power of m, that's 1. That's going to go underneath. And my index, the number that sits right here, the index, n for index, that is 2. Let me just match it up right there. Okay? And we can clean it up. We have a lot of little ninjas there, right? What is a ninja that I don't need? What is something that is there that I don't necessarily need? The 1 I'm hearing. The 2 is another one. That's the first ninja that's not a 1, right? And there's one more symbol here that's not necessarily needed. Say it again. No, we need that guy. No, I mean the exponent on the. Okay, the exponent on the variable, like we don't need the 1, right? We don't need the 2 that's in the index. And so we have the 12 and we have this multiplication. And Roman got it. Yeah, the multiplication, we don't necessarily need that, right? Because that's assumed. When you have it right up against here, we assume it's multiplying. When we don't have anything in this index position, we assume it's 2, right? And then when we don't have anything above the m, we assume it's 1. So there's a lot of assumptions, right? But essentially, this right here is the radical form in its cleanest version. Questions on that? All right. Y'all ready to try 1D? Yay. Okay, great. So let's go ahead. I'm going to pause this. All right, so here we are for the very first time looking at example 1D. And the idea, the difference here is that everything is under the radical. Let's put in those ninjas. We have a 2 here, and we have a 1 right here, and we have a 1 right there, right? So here's the idea. We have more than one base, right? We have more than one A. So I'm going to pull that 32 down, okay? And keep in mind, these right here, if it's under the radical, it's the M's. And both of them are going to have the same N being equal to 2. So I'm going to pull 32, and I've got to the power of 1, W to the power of 1. Notice I'm leaving room for a new denominator. That denominator is going to be your index. And so I'm going to pull that 2 as my denominator. And that kind of matches up because remember how we said that if the exponent is a fraction, it can be under the radical. And look, it was under the radical, both of them, right? With this one, this never had a fraction as an exponent, so it was never invited underneath the radical. Does that kind of help a little bit? A little bit simple? Okay. Hearing it. Now, this technically could be expressed as this as well, where you just put it in parentheses to the power of 1/2, because you would use that power of a power rule, right? Okay. Any questions on this? All right, let's go ahead. Let's keep going. Do y'all remember factor trees from when you were little? Yes. When math was fun? Remember that? Oh, someone. When you would get a little sticker and your teacher would tell you you're so good. Okay, so factor trees, nice and easy, right? Okay. What is a number that I could probably divide 256 by?
128.
Seriously? That's what comes to your mind? I'm like, wow, I'm impressed. She's just like, oh, 128? Wow, that's not what came to my mind. I was thinking like 2.
I was gonna say 3.
Okay, if you have an even number, for those of us who don't live where she is, if you have an even number, you can divide by 2, right? I like Roman's idea of like, dividing by 12 or by 4, right? Because, this is kind of a big number. We're going to be here all day if we do it by 2s. So maybe let's try doubling it, right? Let's divide it by 4. So I'm going to put it in my calculator because I'm not Samantha. And I'm going to say 256. I'm going to divide by 4. I get 64. Well, there's the other little branch to my tree, right? And then I'm just going to keep dividing 64. Or if you know what the factors are, But you can easily divide that. And so A and S means it's the last answer that was in your calculator. So that's really like 64 divided by 4. You get 16. So that's 4 times 16, right? And then 16 divided by 4 is just 4, right? Okay. So these are my little berries. Kind of stopping there. Okay. And what we're going to do is we're going to rewrite this, because what basically this tree is saying is that 4 times 4 times 4 times 4 is 256, right? So I'm going to multiply 4 times 4 times 4 times 4. And my index happens to be 4. What a quinky dink. Okay. This index tells us how many factors that are the same must be present before they can leave the radical. Okay. So I have 4 of these factors of 4. And so what's going to pop out, boop, is a 4. Yes? Now let's say that, you know what, we were determined to work hard and we took it down to all the 2s, right? And all the 2s and all the 2s. Okay? And so what this means is we still have the 4th root here, right, that we're looking for. And I got 2 times 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 2, right? That's 8 2s. So I'm looking for those groups of 4. So I'm going to pull out. I got 4 2s right here. So what's going to pop out? Boop, a 2. Okay. Can y'all see that, y'all? And then here I got another group of 2s. Boop, comes another 2. And it actually sounds like that. Now notice in between the two 2's, I put multiplication. That's because 2 times 2 will give me, ta-da, same answer, right? 4. So even if you had taken it all the way down to the nitty gritty, you absolutely would have gotten the same answer of 4. Any questions on that? Okay, so I'm gonna remember to unpause this when I get done. I want you to start with a little factor tree, and let's discuss what number might be good to divide this by. Since it ends with a 5, 5 might be an option. If we wanted to go a little faster, since this is like some god-awful number like 15,625, what might be a little easier number?
20.
20 is an even number, so that won't work. I think 25 might be good, right? Because if it's divisible by 5, maybe, and then Roman, there you go. 25, yeah? So that's just my advice. Do as you wish. I'll give you a little time, okay? I'm gonna pause. Yay, welcome back. All right, now, I did 25. So I did in my calculator 625, right? Divided by 25. Whoop. So I made my little tree. I got 25 times 625, right? You could have done 5s. That works too. I'm going to divide this by 25 again. And I get 25 times 25. The only problem is I've got the 6th root, right? So I'm looking for groups of 6. 25 times 25 times 25. Does that help me at all? No. So let's break it down a little bit further. Good thing that we know that 25 is actually made up of 5 times 5. Yay. So 5 times 5. 5 times 5. 5 times 5. You with me? And so I'm going to take all those little 5s, and magically I have enough now. Because I have exactly 6 5s, right? So what's going to pop out? Boop. Oh, 5. Yeah. So basically, if you can find a group of 6, out will pop out one of the factors, and the whole thing is 5. Questions? Okay, I gotta say, I really think y'all are doing better than anybody all day. So congratulate yourself. All right, so here we go. Let me show you how to put it in your calculator. Are there any questions on this one? Okay, y'all sound enthused. Let me go ahead and show you. This one right here, it is a radical. However, it's just the square root, right? Square root of 9 is 3. There you go, okay? Now, let me go ahead and show you how to put in a radical that lets you put in a different index, okay? What I would recommend is that you type in the index first. So I'm going to put in 6. Let's see if it does this. Am I recording? Yeah. Okay, and then I'm going to hit math. And notice option 5 where it has an X. They even have some cube root stuff in there, but we're good with X, right? So number 5. And then notice how it put the 6 automatically as the index. And now I'm going to type in 15,625 without the comma, y'all. I've had some people, okay? And then you step to the side, make sure, does it match? Yep. And you hit enter and you get 5. Any questions? She's like, I could have done that the whole time. But let me show you when it doesn't work, right? It doesn't work. Let's say that we have something like x, right? Okay, so if I had like this, the 6th root of x to the 6th power, any idea what's going to pop out? Error. That's a good one. No, there's an actual answer for it. Nope. Let me spread it out for you and see if you get it. X times x times x times x times x times x times x.
6x.
Okay, so I have 6 x's that are being multiplied, right? And that's exactly the size of group I'm looking for. So what's going to pop out? Anybody? X. The answer is x, right? That's it. The answer is x. So you look at you just have to have 6 of the same factors, right? Because that tells you, hey, you need to find a group of 6, and then out will pop out one of those from under the radical, okay? Here's the only problem, and this happens every single time I'll have a student who is just like, shoot, I'm going to get the calculator to do it all for me. And then they go in here and they put in a little 5 and oops, I got to go back in there and put in 6, right? I got 6. I'm going to go in here and I'm going to put in X and I'm good. And then it just lies to you because the calculator thinks that X is 0. And so it's always going to give you an answer based on X being equal to 0. It just lies to you. Okay. So don't do that. Bad calculator. The other thing that might happen, right? Let's say that I've got a problem that looks like this. I've got, let's say I have, I don't know, to the 3rd power. Let's keep things simple. And I have 2 times 2 times 2 times 2. Do you know, I've got one group of 3, right? And so from that group of 3, out's going to pop a what? A 2. Okay. This 2. So I'm going to look at it. Basically, those go away, right? I still have my radical with a cube root. And then I've got 1, 2. Does this 2 that's inside get to go home or leave the house, leave the radical? No, because it's not a group of 3 and it never will be because that's a prime number. Yes? So this may be the answer choice on your test, right? This could be. Watch what your calculator does, okay? Because this essentially, y'all know that this is the same as the cube root of 2 to the 4th power, right? Okay, so I'm going to enter it like that. I'm going to go in here. I'm going to put in my index 3. I'm going to hit math. And I'm going to hit 5. And then I'm going to put in 2 to the 4th power. Okay? Look okay? All right, hit enter. Oh, it's a decimal. And so, yeah, it may not be the most helpful to you. That's what that is. Because if I do this, I could also do 2. Let's see, 2. Let's see how it'll do it. 2 to the 3rd power math. You know what? I want to do it like this. Okay. And then I'm going to take out the exponent of this, delete. Okay. So here, okay, you know what? I'm feeling like I need to put a 1. See, same thing. See it? All right, any questions on this? Okay, thank you so much for joining me today on the video. You have a beautiful day and I'll see you tomorrow. Okay.